The overall objective of this project is to really better understand how does liming affect soil fertility and specifically soil pH in this region. Precipitated calcium carbonate, or spent sugar beet lime, is a byproduct of the sugar processing facilities. And so they will add calcium oxide to their sugar stream. And so the reason they add this calcium oxide is it precipitates all of those impurities out, leaving a clean sugar stream that can then be dehydrated and turned into the sugar product we all enjoy and love. But that impurity that is precipitated out is that product that we're applying here. Liming is fairly new to Eastern Idaho, and so we don't know how much lime is needed. We don't know the appropriate rates. We don't know how long do these applications last in order to help these growers to remediate their acidic soils. Acidic soils can negatively impact crop production, especially here in this region or in the Soda Springs region, which are the two areas where we're targeting with this study. In these regions, we primarily only grow dryland barley, or we may have dryland barley and dryland wheat. And when the soil pH gets below 5.2, the roots, there begins to be too much free aluminum. And so instead of having nice healthy roots that are able to intercept the water, which is in short supply, as well as the nutrients, the aluminum causes these roots to clump. And so they really can't pull up the water, they can't get the nutrients, and so we end up with severely reduced yields on an already challenging agricultural system.
We find that we are low pH, and so we find that there's more grain diseases. Where the grain is not thriving very well, the weeds thrive, and so the yields are diminished a lot.
A lot of the producers have been using the lime, but they just don't know the proper application rate, and so we're trying to help them to be able to save money by applying just what they need.
I act as a professional on one of the professional producer grants. So I help to design the experiments and analyze the results. So in order to conduct this study, we needed to know what were the initial conditions for each of the fields that we were going to be on. All right, so the first thing that we're going to want to look for is using your knowledge, because you guys are the experts on your field, to identify where the problematic spots are, especially in terms of weeds, or if it's, you know that we've historically had bad yields. So we want to identify those areas for the study so that we are targeting the most acidic portions of the field or the worst portions of the field in the hopes that we can actually see the best results from liming. So let's go ahead and we will flag out some of these spots. So we've got some weeds right here, so this might be a good spot to identify. So we've got some barnyard grass. Sometimes we'll get corn spurry. So these lower spots where we have more green, better fertility, but also typically more issues with the acidity. Okay, so we selected this spot because there's not quite the stand, it's a thinner stand. So I'll open my Google Maps. I'll place my pin here and say, this is where I'm gonna come back to year after year, knowing I'm gonna be sampling around all these points. For the field study though, we want to have a more gridded type pattern where we're actually addressing variability going across the field. And so when we go into to actually put in this field, we've got some nice hill slope here. And so it would be valuable to come up to the top of the hill and take a sample up here, something down here in the bottom, and then going out through the saddle and then going back up. And so in a field trial, our plots are actually going to be 400 feet long, and we're going to go every 100 feet and take a soil sample there. And that's going to be our gridded zone going across this field. And so we'll come back to those gridded points every time, but this might be one of those areas that's like, oh, this is of interest. We want to make this one of our points, one of the 3 100-foot points. Later, just like we've come through and harvested with the large combine, we'll take our plot combine through here, right down this alley, going all the way down, and every 100 feet, we'll make that a harvest section. And so that's what we've been doing in your field, Brody.
As a farmer, we're so busy with 10,000 other things that this is just one of many things, and it's nice to have some help to fine-tune this so we're not wasteful, so we can be sustainable. This hilltop might not need near as much lime as right down where they're spreading here. But it still needs some, but it might only need 2 ton, and that might need 6 ton. And to be able to have somebody come in with the technology and studying it, I'm really excited about the research that's going to come out of these studies and see what we can do to fine-tune this and be more efficient.
So that we can have a better picture of what's really going on in this long stretch, instead of just me coming out here and saying, here's this little 5-foot section, or 5 by 5. It's a good estimate, like what we've been doing on your fields.
On my fields anyways, they came and they took soil samples before they applied, and then they've been just taking soil samples, and then they also come out at harvest time and take samples of the yield to try and get the yield of each plot. And then that way they can tell how the lime is affecting the pH and how the lime is affecting the yield.
And for our soil sampling scheme, we wanted to know what was the soil pH in the top 2 inches, 2 to 4, 4 to 6, and 6 to 12, as well as the 0 to 6 inch depth. So let's go ahead and take a composite sample. I'll go grab the bucket and bag them up, and then send them to our lab where it'll be analyzed. In this case, the main thing that we want to look for is soil pH, but some other things that would be of interest to pay attention to, especially for these fields, are on very acidic soils. If we're below a 5.2, looking at exchangeable aluminum, because that is a toxicity, or it can be a toxin to the barley and wheat. But then also running what's called a buffer test. We've been working on getting the SARE buffer test calibrated for this region, and that's what part of the studies have been working on. And so eventually we can just run the SARE buffer test, and it tells us, okay, if it comes back with a pH of 6.1 or 5.5 or something like that, we can then look at a table and say, okay, that equates to this much lime that we need to apply, rather than having the guesswork. And so hopefully that'll help with your decision making and deciding how much lime to apply to each field. Then we would have them apply different lime rates. And in this case, we are applying 0, 2, 4, and 6 tons of as-is lime, or precipitate calcium carbonate, per acre. We have our plots going down the center of that 50-foot swath, and he'll change his rates as he goes across to match our plots. As he's coming down here, he's gonna probably be plotting 2 tons to the acre with his spreader. And then if the next plot over is 4 tons, we may just have him go over it twice so that he doesn't have to recalibrate. And if the next plot's 6 tons, then he goes over it 3 times. So immediately after applying the lime, then we allow the producer to do whatever practice they would typically do on their fields. And so if that includes a tillage pass, or if it doesn't include a tillage pass, whatever it is. And so this allows them to see how their practices are going to impact that lime application over time. Every fall, we come back and we take a measurement from each of those pre-pointed GPS points, and we track how does the soil pH change, how does the free aluminum change, and we're also looking at the electrical conductivity of that soil. Eventually, many of these soils can get to the point where they stop producing the predominant crops, especially if we let them get too acidic. It's very localized areas where there's these low pHs, but there's nothing that grows in those spots because it can no longer support crop life or weed life. And so our goal is, we know that these soils are acidifying. They're not necessarily hugely problematic yet in this region, but we want to get ahead of that before they become really expensive to remediate.